Hey guys, today we are talking about exponential decay functions. All right, remember that an exponential function is of the form y equals a times b to the x power. Well, an exponential decay function is where a is greater than 0 and 0 is less than b is less than 1, which means that it falls somewhere between 0 and 1. All right, b has to be somewhere between 0 and 1, meaning that it's going to be a fraction or a decimal that is less than 1, but still positive. Okay? Let's say we have y equals 1/2 to the x power. Okay, so this is y equals 1 times 1/2 to the x power. Since there's an invisible 1 in the front, as always, outside of the parenthesis, it's not imaginary, but it is invisible because it is there. So a is 1, b is 1/2. And that satisfies the fact that a has to be greater than 0 because 1 is greater than 0, and b has to be somewhere between 0 and 1, and b is right in the middle of 0 and 1. So let's plug in some x values and graph this. So my x values, I'm going to choose our -2, -1, 0, 1, and 2. So I have y equals 1/2 raised to the -2nd power, 1/2 raised to the -1st power, 1/2 raised to the 0 power, 1/2 raised to the 1st power, and y equals 1/2 raised to the 2nd power. All right, so remember that if there is a negative exponent and we have a fraction, we flip the fraction, which is 2 over 1. 2 over 1 is just 2. 2 squared is 4. So our y values start off with 4. Remember, if I have a negative exponent, that means flip the fraction. So that's going to be 2 over 1, which is just 2. Remember that if 0 is your exponent, then that automatically makes it 1, because anything raised to the 0 power is 1. Anything raised to the 1st power is itself, so this one will be 1/2. And now remember, 1/2 squared means 1/2 times 1/2. All right? And now when you multiply fractions, you multiply straight across. So 1 times 1 is 1, and 2 times 2 is 4. You can also remember that 1/2 of a half is a quarter. So we'll plug in our y values here. And now let's plot these points. -2, 4, -1, 2, 0, 1, 1, 1/2, and 2, 1/4. So I will connect these points with a curve, and we'll put arrows in the end to show that it goes on forever. You will notice that right here that our curve curves down, and it is always approaching the x-axis, but it never crosses the x-axis. And the reason for that is because x can never have a value that will cause this function to equal 0. So because it can never be 0 or lower, we call that a horizontal asymptote. And our horizontal asymptote is at y equals 0. So that means that our range is y is greater than 0. But our x values can be any number. So we would say our domain is all real numbers. You'll notice that the further we go right, the lower the y values get. That's what makes this an exponential decay function.